All right, this is the Unit 2 review. So for the test, what's the equation in vertex form of a parabola with a vertex of -2, 5 that passes through 0, 6? So we can see here we've got a vertex, and we want the vertex to always be at hk. So we'll just put h and k underneath those two. We have another point over here, so we'll call that point xy. And so what we want to do is we want to write down vertex form, and then we're going to plug everything into vertex form, kind of like we did for the quiz. So y equals a, parentheses x minus h squared, because that's vertex form, plus k. We'll fill in the vertex, we'll fill in h and k. Y equals a, x, so h is -2, so minus -2 would be +2. K is 5, so we'll add 5. Then we'll substitute in for x and y, so y is 6, and x is 0, so 0 plus 2 squared plus 5. So first thing we want to do is minus 5 on both sides. So 6 minus 5 is going to be 1. 0 plus 2 is 2. 2 squared is 4. So we'll divide both sides by 4. To get 1/4 is a. So what we're going to do is take a, we're going to plug a back into the equation. So we'll take the a that we've got right here, and we're going to plug it right back into this red equation, and that's going to give us our final answer. Y equals 1/4, parentheses x plus 2 squared plus 5. And so we're all set there. And if you wanted to double check that, you're more than welcome to double check that with the graph. So you can make the graph of that equation and see if it actually does pass through 0, 6, and if it does have a top or a bottom at -2, 5. So it should be a minimum because 1/4 is positive. So it should be at the bottom. All right, number 2, function g is transformed from f of x equals x squared. The graph of g is a translation right 3 units and down 4 units of the graph f. Write the equation for g in the form y equals ax squared plus bx plus c. So this time we have to take it and make standard form out of this. So we're going to start by just doing the same form that we did before. We're going to start with vertex form. So y equals a parentheses x minus h squared plus k. And what we're going to do is we're going to look inside the question for h and k. So right here it says we're going to go to the right 3 units. So if we're going to the right 3 units, we know we want, oops, not minus h, minus 3 in the parentheses. So there we go. For k, since we see we have down 4 units, we want to go -4 for k. And since you have no information for a, there's no vertical stretch and no flipping or anything, a is just 1. So if we want, we could put a 1 in for a. We could also just leave a out of the whole thing. We could just not put anything there. So we want to get it into standard form, which means we need to then expand this. So since there's a 1 here, we get to ignore it. And we're going to write x minus 3 squared as x minus 3 times another x minus 3. And at this point, then we can multiply those two binomials together however you want. So you can multiply with the boxes, you can do FOIL, or if you want, you can do the double distributive property. So what we want to do is split up the first x minus 3 into x and x minus 3. And then we're going to distribute the second x minus 3 with the minus 3. The -4 is still here. So I did notice a couple people forgot about the -4 on the quiz. But the -4 is still traveling with us. And then we're going to distribute. So x times x is x squared. X times minus 3 is minus 3x. -3 times x is minus 3x. -3 times -3 is 9. And then we still have -4. Last thing to do is to combine any like terms. So we've got x squared. Minus 3x is minus 6x. Plus 9 minus 4 is going to be plus 5. And so that'll take us to the end. So that's it. We're in the correct form. For question 3, what's the vertex of this graph? So since we want to find the vertex, we can use the vertex equation. So we'll start by finding the x-coordinate. X equals -b over 2a. So b in this case is -8. And then a in this case is going to be 1. So we get 8 over 2, which is 4. So I know it can't be this one, and it can't be that one, because those are negative 4s. So next thing I got to do is then take the 4 and plug it in for the x's into the equation. So we're going to plug 4 in for both of those x's. So it'll be 4 squared minus 8 times 4 plus 9. So this is going to be 16 minus 32 plus 9. Well, 16 minus 32 is negative 16. Negative 16 plus 9 is negative 7. So we want to pick the one with the negative 7, which is going to be C. So that's how we get our y coordinate. Again, we're plugging it back into the function value. So we could say f of x equals over here. We wouldn't say f of x. We'd say f of 4, because we're actually plugging 4 in for x. So we get negative 7. Oops. I just want to say, and you can double check that again with the graph too. Same deal with number 2. You could have double checked it with the graph to make sure they're the same parabola. The path of a projectile launched from an 8-foot tall tower is modeled by the equation negative 16x squared plus 64x plus 8. Part A says graph the equation. All right, well, I'm probably going to use Desmos to graph it, but I do know one point right away. I do know that we get 8 as the y-intercept. So I'm going to plot that one out right away. If I wanted to do it by hand, what I would do next is I would get the vertex. We could do that. I mean, that's not too crazy. Negative b over 2a. So negative b over 2a is negative 64 over negative, oops, not negative yet, 2 times negative 16. Which is negative 64 over negative 32, which is just 2. So we know that the vertex is somewhere at 2. So it's going to be somewhere on that line. All right, well, let's actually figure out what that is. What we're going to do is then plug the 2 in for these two x's. So y equals negative 16 times 2 squared plus 64 times 2 plus 8. So y equals, well, 16 times 4 is 64. So that's negative 64. 64 times 2 would be 64 and another 64, and then plus 8. So I know those are going to cancel. So that means we're going to get 72. Oh, all right. Well, I guess we've answered that question. What is the maximum height is going to be 72 feet. So we kind of did that out of order, but that's okay. So 72 will be right there. And since it's a parabola, I guess we could have done this one first once we found out our x value. Once we know that x is 2, we can actually reflect this over 2. So if I'm 2 to the left of the axis of symmetry, I'd also have to go 2 to the right for the axis of symmetry. So this point over here is at the point 4, 8. And that has to be true by symmetry. We can draw a parabola in, and then we should be about done. There we go. If we want to be perfect, since we're modeling the equation of a projectile, we don't want to have any time before 0. And we also don't want to go below the ground. You could say that you're shooting into a valley, I guess, and then go a little bit below the ground. But in the context of the real world, that's what the final equation is going to look like. I am going to throw that into Desmos just to double check everything. And because since this is a real world problem, Desmos is probably the way to go on this one. So negative 16 x squared plus 64 goes minus 64x. I do it with plus. Plus 8 feet for the tower. And we can see, yeah, it looks like it's a little bit past 4. We hit the y-axis. If we go up to 8, yeah, 0 8's on the graph. 4 8's on the graph, so that's good. I got to zoom out a little bit. Maybe one more. So pretty skinny parabola here. But we do get to 272, and that's exactly the point that we plotted. So over here we got y equals 72. Black number was 2. Let me just write that as a coordinate up here in green. And so that's exactly the coordinate that we got. If you wanted to use Desmos to do it, you would need to get the x-intercept. So you probably wouldn't plot 4, 8 in blue. You probably would be plotting down here 4.121 comma 0. This point over here doesn't make sense because, again, that's a negative time, so you would not want to plot that on the graph. So these 3 solid dots, or 3 dots that show up on Desmos, probably the ones you want to get. The y-intercept, which is easy from the equation. The maximum, which, again, if you're using your TI calculator, you can use the maximum feature to get. And then the y-intercept, which if you're on the TI calculator, again, you can use the 0 button to figure that one out too. But that's question number 4. Oops, wrong button. All right. So for number 5, use quadratic regression to find the equation of a quadratic function that fits the given points. Nothing to do but to throw it into Desmos. We're going to throw it into Desmos. So we got 0, 1, 2, and 3 again. So that makes the table kind of nice. 0, 1, 2, 3. And then for our points, 7.8, 34.9. For our other 2 points, 82.1. 60 something, 68.3. All right. Turn the red parabola off. It looks like the red parabola is actually pretty close. But y1 tilde ax1 squared plus bx1 plus c. All right, well, it's kind of close to the other one that we had. I'm going to grab those with the little camera feature. Let's just grab everything that we got there. Again, we can see since we've got 4 points, it's not going to fit exactly. And that's okay. So I've got my things, and if you're using the TI calculator, again, this is what we do in the stat menu. Stat over and then 5 after you've got all the data in. And we'll just write down everything we got here. So it's going to be y equals, a is negative 10.225, x squared. B is 53.545. And then C is 3.745. So this is like the best guess. This is the curve that best fits those 4 dots that we've got. So when we want to model this, that's going to be our final answer. You just go ahead and say I'm done. And that's it. So for 6, solve the equation x squared plus x equals 30. If I want to solve it by hand, I need to make sure I'm equaling 0. So I'm going to subtract 30 from both sides to get x squared plus x minus 30 equals 0. We'll make the t-chart here because we're doing a quadratic. I need to find things that multiply to negative 30 and add up to 1 because I've got 1x right here. Numbers I want to pick, 6 and 5, and 6 has to be bigger, so I'm going to pick negative 5. 6 plus negative 5 equals 1, so that double checks that I did pick them right that time, so that's good. And then from here you can factor however you wish. Since x squared is just a regular 1x squared, we can just jump right to the answer though. X plus 6, x minus 5 equals 0. Use the 0 product property to solve. Set them both equal to 0. Minus 6 on both sides. X equals negative 6. X minus 5 equals 0. Add 5 to both sides. X equals 5. And those are the 2 answers. And that's it. Again, it is solve the equation. Since these numbers are real numbers, you can solve it with the graph as well. But this was actually pretty easy, so we'll just stick with this method. 7, you can see we have another word problem, so it's another real-world situation. Ball's thrown from the top row of seats in a stadium. The function h of t equals negative 16t squared plus 64t plus 112 gives the height in feet of the ball. T seconds after it's thrown, how long will it be to 3 decimal points before the ball hits the ground? So I'm just going to throw this into Desmos again because it is a real-world question. This time it wants to know when it hits the ground. So it wants to know where it's at 0, not the maximum. So negative 1664 and then 112. So all I got to do is switch this to a 112. These off. Turn this back on. And the only point that I really care about is down here where we're equal to 0, 5.317. And that's it. So we're all set. Seconds. Oh, I just know the negative 16 is in feet per second squared. That's why I put seconds on there. It doesn't, I'll just say seconds up here. There we go. That's where the units come from. But that's it. That's everything with number 7. If you want to solve it by hand, probably have to go with the quadratic formula since that is a decimal. And then to figure out whatever the square root is, you'd have to use a calculator anyway. So probably best to just throw that in and look at the graph. Next, identify the intervals where x squared minus 3x minus 28 is positive. We're going to make our t-chart again. So we're going to multiply to negative 28, add up to negative 3. 7 and 4 seem like good choices. 7 should be negative because I need the answer of addition to be negative. So the bigger number's got to be negative. So negative 7 plus 4 is negative 3. Zero product property, just like that last question. 0 minus x minus 7. X plus 4 equals 0. X minus 7 equals 0. X equals 7. X plus 4 equals 0. X equals negative 4. All right, well, so those are my two numbers that I need. So again, we want to make our little sign chart. The lower of the two numbers is negative 4. The higher is 7. So I need to find numbers in each region. Well, the first one, the easy one, is 0, because 0 is between negative 4 and 7, and it's always the y-intercept. So it's negative, because negative 28 is the answer for that one. Next, I got to pick numbers on either side. Again, I like to pick 10 and negative 10, so I'm just going to go with those because those do work. If I plug 10 back into the equation, I get 10 squared minus 3 times 10 minus 28, which is 100 minus 30 minus 28, which I can tell is positive from there. If I put negative 10 in, so negative 10 squared minus 3 times negative 10 minus 28 is 100 plus 30 minus 28, which is also going to be positive. So now I need to analyze. It says where I want positive, which is right here and right here. So since there's two regions, I got to have my two answers union together. So negative infinity to negative 4, unioned with 7 out to infinity. So again, if it wanted to know where it was negative, negative would just be parentheses negative 4 to 7, because you would just take the one inside the middle region. So that's all you would do for that one. All right. For 9, use square roots to solve this equation over the complex numbers. The whole idea is we square root both sides. Square root of x squared is x, and we're going to get plus or minus square root of negative 16. Now you might know what that is already, but just for good practice, I'm going to go ahead and do it out fully. So we get square root of negative 1 times square root of 16 is square root of negative 16. And our friend shows up over here. So square root of negative 1 is I. And we actually know the square root of 16 is 4. So x equals plus or minus 4i. And that's it. You're actually done at that point. So that's all we have to do to solve that one. If our square root gave us a decimal, again, we wouldn't want to write it as a decimal. We want to write it in simplest radical form. All right, write the product 6 plus I times 6 minus I in the form a plus bi. You can do this either with the boxes with FOIL or the double distributive property. I'm going to double distributive this one. So 6 times 6 minus I plus I times 6 minus I, and we just distribute. So 6 times 6, that's 36. 6 times minus I is minus 6i. I times 6 is plus 6i. I times minus I is minus I squared. So 36, can't really do anything with that. We bring it down. I combine like terms here, this is interesting because minus 6i and plus 6i cancels out. I'm going to write plus 0i. I don't have to, but I'm just going to do it because it doesn't always cancel out. So you could end up with i's, but for this one, it does cancel out. It doesn't always cancel out. This one just happens to. And then over here, I've got the I squared. So the other tricky part about this one is we have to remember that I squared is equal to -1. So when we work with regular variables, we're allowed to just leave this as x squared, but since we have i's, we have to replace this with a -1. So the negative sign I'm going to leave in green because that's different. And what I'm going to do is replace this I squared with -1. So I'm going to do minus -1. So I got to be really careful with my negative signs here. All right, well, 0i is just 0. So at this point now I am going to fully drop that out of the question. Minus -1 is the same as +1, but 36 plus 1 is 37. Now notice we didn't have any i's, so if you really wanted to, you could write this as 37 plus 0i. That would also be correct, because in this case, a would be 37, b would be 0. Now again, if a or b is 0, you don't need to write the 0. It's not always going to be 0. This one just happened to be 0. It's not always going to be 0. And again, I'd get that 0i just from that middle term there. These two would still combine to make 37. All right, for 11, now we have to divide, write the quotient in the form a plus bi. So when we want to find the quotient, when we're dividing, we have to do the complex conjugate because we want to get our i's out of the bottom. Oops. So the opposite of minus 3i is plus 3i. So I'm going to multiply both the top and the bottom by 2 plus 3i. All right, well, this is going to be a little bit of work because these questions do take a little bit of extra time. So on the top, we're going to do 5 times 2 plus 3i. So we can distribute that to both pieces to get 10 plus 15i. All right, well, that's pretty good because that works out almost exactly as if that was an x instead of an I. We didn't have to do any switches or anything. On the bottom, we need to multiply both of these together. So that means we're going to have to just double distribute again. So we're going to get 2 times 2 plus 3i. We're going to get minus 3i times 2 plus 3i. So when we double distribute, 2 times 2 is 4. 2 times 3i is 6i. Minus 3i times 2 is minus 6i. Minus 3i times plus 3i is minus 9i squared. All right, sometimes it takes a little bit of time for them to load up, but all right, like I said, 9i squared. There we go. All right, so unlike the one before it, this time these two things better cancel out because that's the whole point of doing this is to get rid of these I terms. So 4 is good. This plus 6 and this minus 6, every single time on this question and whenever you're dividing, those things should cancel out. I see I've got an I squared in there again. Remember, we're going to turn I squared into -1. So we've got minus 9 and then parentheses -1 because we're replacing I squared with -1. All right, well, 4 stays as 4, but -9 times -1 is +9. So we're going to end up with 13. So we get 13. And I'm perfectly happy if you give me this as the final answer. If you want to write it in the specific form, a plus bi, it's going to be 10 over 13 plus 15 over 13i. But I'll take either one. I'm not too picky on this question. Both of those would be good enough for me. If you do it in the calculator, just watch out. You got to make sure you turn them into fractions. I will not take decimal answers. Decimal answers do not count. They will not be exact. So, all right. For 12, factor the expression 25x squared plus 49. So the best way to do this is to remember it is a memorization factor. A squared plus b squared is going to factor into a minus bi, a plus bi. So if we take the square root of each of these, square root of 25x squared means that a is going to equal 5x. Square root of 49 is b. Square root of 49 is 7. So minus 7i plus 7i. And that should be about it. So if we really wanted to double check, we could. I don't think I'm going to. I'm pretty happy with this. I'm feeling pretty confident because it's just a memorization one. So I'm going to roll on. For 13, what value of c would make x squared minus 12x plus c a perfect square trinomial? So what we want to do is we want to set up our sideboard. So we've got negative 12 is for b. That's our value for b. B over 2 is going to be negative 12 over 2, which is negative 6. B over 2 squared is going to be negative 6 squared, which is 36. And that's actually it. That's the answer, is 36 is what we would have to add to make that a perfect square trinomial. So done with part A. Part B, solve 0 equals x squared minus 12x plus 22, give an exact answer. So we have a choice here. We can use either the quadratic formula or completing the square. For this one, I'm probably going to recommend completing the square because we've already done most of the work for completing the square, so we may as well finish it up that way. In that case, we say 0 equals x squared minus 12x plus 22. And then what I got to do is I've got to go ahead and get this 36 in there somehow. So remember, what we want to do is we want to both add and subtract that 36. So I'm going to add and subtract the 36 that I have over here. So again, if I was starting from scratch, I would still have to do all of this work first. But you can see I got plus 36 and minus 36. The reason we do that is because this is going to become x minus 6 squared. Remember, minus 6 over here for our b over 2, going inside the parentheses. Negative 36 plus 22, that's 14 as a negative. So we get minus 14. I want to add 14 to both sides. And so, again, this is just a process. So you're doing the same process every single time with this, which is why completing the square is nice. We're going to square root both sides. And again, we square root both sides every time because we want to get rid of this squared. In this case, square root of 14 doesn't simplify at all. So we just have plus or minus square root of 14 is equal to x minus 6. We're going to add 6 to both sides, and we're just going to write it as 6 plus or minus the square root of 14 is equal to x. And that's what we want. So again, decimals here would be no good. If you gave me a decimal, you did not give me an exact answer, so it's not going to be correct. You actually need to have the exact answer. If you were to do it with the quadratic formula, you would get the same answer. But again, for this one, since we already started it, may as well keep doing completing the square. Also, since b is an even number, b is 12, or I should say b is negative 12, I'm going to choose completing the square over the quadratic formula. I just think it's going to be, I think the completing the square is easier than the quadratic formula whenever b is even. So that's why I'm going to stick with that one. 14, we've got this function, which statements are true, select all that apply. All right, so looks like we've got our equation in vertex form, so we're going to have to do that. Graph of the function is a minimum at this point, 17/4, 5/2. So again, it looks like I'm trying to get the vertex, because this will be the y-coordinate of the vertex. Range of the function is all real numbers. Well, I mean, that's definitely not true. We have a quadratic, so the range is never negative infinity to infinity. Domain would be, but not the range. Range is always a number to infinity or negative infinity to a number. So we'll dump D right away. So we have to get this in vertex form. We got a couple options. We could complete the square, but that doesn't seem like a really good option for me because, again, this time B is an odd number. B is 5. So I think the better play here is we're going to use negative b over 2a to get the x coordinate of the vertex. When we do that, turns out we're going to get negative 5 over 2 times 1, because again, remember, a is 1 in this case, which is negative 5 halves. Right away, that's not negative 5 halves. So we know it's not going to be c. Well, all right, well, we got the x coordinate. But wait a second. Again, if we want to write this in vertex form, y equals a x minus h squared plus k. This is h. We know a is 1, so 1 right there. We got minus 5 halves, so that would be plus 5 halves. So we can't get b either. So at this point, I've kind of eliminated everything down to just 1. It does say select all that applies. I mean, it could be a trick question. We could just not have to pick anything. So let's not pick this yet. It might be one of those where it's like none of them are right, so you're supposed to leave it blank. I don't know. We'll find out. But anyway, we're almost done with the problem. We do have to plug negative 5 halves back into the original equation, though. So we get y equals negative 5 halves squared plus 5 times 5 halves plus 2. All right, well, this is going to be a little bit of work. 25 over 4 plus 25 over 2 plus 2. All right, we got to get a common denominator, so 25 over 4. If I do 2 times 2 is 4, so that's going to be 50 over 4. All right, 2 times 2 is, well, we got to do over 4, so multiply by 4, so it'll be 8. So let's see what we got. 25, 75, we got 83 over 4. All right, that doesn't seem right. They got minus 17 over 4. Let me double check. My signs all good? No, my signs are not good. I made a mistake. That's a negative right there. That's going to change things. All right, well, it's all right. Just change the signs, not a big deal. Okay, let's go back through it again. We caught the mistake. 25 minus 50 now is negative 25. Negative 25 plus 8 is negative 17 over 4. All right, I feel a little bit happier because at least I did get one of the answers. Probably not going to be a trick question with nothing. So yeah, we do get A. So that's kind of the end of that one. Again, for this question over here, what we would do then is, since we know that this is the y value, I could say, not plus, but minus 17 over 4. And if I had to answer the question for this vertex, I would answer this as negative 5 over 2. That's what I got for the x. And then minus 17 over 4, because that's what I got for the y. That would be where the minimum was at. So that's what I would go with. Obviously, if you want to graph this, you're welcome to graph it and double check each of these. You can check A and B pretty quickly to see if the parabolas do line up. You can check C pretty quickly also, just to check the vertex. D, you still have to know what range means, but you can also see that D is incorrect if you were to graph it. For 15, solve this, give an exact answer. So I can't solve by graphing because, again, I need an exact answer, and it doesn't always work if we can graph it. So first thing I would do is try factoring, but if I look, 3 things that multiply to 3 and add up to 7, I don't know anything that would do that. 7's also odd, so I think I'm kind of stuck using the quadratic formula. And that's okay. Sometimes we just have to run through the whole quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, let's start plugging them in. So a is 1, b is going to be 7, and c is going to be 3. All right, plug them in, plug them in. So let's see, we've got negative 7 plus or minus the square root of 7 squared minus 4 times 1 times 3 all over 2 times 1. Okay, so we get negative 7 plus or minus square root of 49 minus 12 all over 2. All right, I need to come down. We'll come down here next. Negative 7. It's not purple. I want to use the purple one. Negative 7 plus or minus the square root of, so 49 minus 12 is 37 over 2. And this is the point where we're actually done. That is an exact answer. So we're all set. We may not like that answer, but that's it. The reason we know we're done is because 37 doesn't really break down into anything. If 37 were to simplify into something, then we could keep going, but it doesn't, so we don't. That's it. Next, same deal. Again, kind of same idea. I see this as a negative 5. If I try to think of things that multiply to 9 and add up to negative 5, I'm out of luck. So we're just going to go ahead and use the quadratic formula one more time on this one. Negative b plus or minus the square root of b squared minus 4ac all over 2a. In this case, a is 1, b is negative 5, and c is 9. So we might get a little bit bored of the quadratic formula, but so we got this one. Negative negative 5 plus or minus the square root of negative 5 squared. Minus 4 times 1. C is 9 in this case. All over 2 times 1. So 5 plus or minus the square root of 25. 4 times 9 is 36 over 2. So 5 plus or minus square root of 25 minus 36 is negative 9 over 2. And so we're not done here because, well, for the first thing we can see is we have a negative sign inside the square root. So we can't do anything with that. We can't say that this is a final answer because our final answer cannot have a negative sign in it. So we're going to take that negative sign out and replace that with an I. And then we also know the square root of 9. So the square root of 9 is 3. And this is going to be our final answer. If you want, you can write it in a plus bi form, 3 over 2i. If you want to see this in a little bit more detail, what I did with that square root of negative 9, we can double check because we can split this up into the square root of negative 1 and the square root of 9. And that's I, and that's 3, and that's where we get our 3i from. But again, I'm not too picky on how you format it. I'll take this one. I'll take that one. I will not take a decimal. Do not give me a decimal. I want an exact answer. So fractions are the way to go for exact answers. Both of these would be fine. For 17, real world problem. So we're probably going to throw it in Desmos. But toy cannonball is launched from the cannon on top of a platform. The equation h of t is negative 5t squared plus 20t plus 4 gives the height h in meters of the ball t seconds after it's launched. What equation can be used to tell whether the ball reaches a height of 10 meters? Oh, so we have to actually do something before we can do anything in Desmos. Well, if we want to know when it reaches a height of 10 meters, I mean, logic tells us we want the height to be 10. So we just replace h of t with 10. And that is an equation that tells us whether or not we reach a height of 10 meters. Makes sense. A 10 is the height. So part B says, does the ball actually reach a height of 10 meters? So this is actually like the last section. We're just seeing if this line at 10 is going to intersect our parabola. And I think that Desmos is pretty good for this. So we're going to have y equals 10 for the first one. I don't want to get rid of any of that. So y equals 10. And we got negative 5t squared plus 20t. So I'm going to make those x's instead of t's. Oops, wrong button. Plus 4. That's a little toy, so we're probably not going to go that much. Let's go home. All right, so we're just seeing if these cross. It does, so that's the answer is just yes. All right. Yes. Well, and again, that's just because they cross. So the reason behind that is there are 2 places where it will reach 10. If I want, I can even grab those and throw those on there to say, hey, this is exactly what I'm looking for. I'm looking to see where those 2 lines cross. But oops, it doesn't ask for proof. It doesn't ask where it reaches a height of 10. It just asks if it does. Because remember, sometimes we don't get a solution. Sometimes the answer is going to be no. So that's it for that one. Just seeing yes or no. For 18, what values of b will cause us to have one real solution? All right, well, this seems like it's going to be a little bit weird. And this is a little more esoteric, but that's okay. What we actually want to do here is, since we want to know one real solution, the number of solutions goes with the discriminant equation. So I have to do as a discriminant problem. The discriminant equation is d is equal to b squared minus 4ac. And so we know if we want one real solution, the discriminant has to be equal to 0. So there's a lot that we have to kind of know in order to answer this one. So I'm going to put 0 in for the discriminant. I know A. A is 9. I also know C. C is 16. Again, what I'm trying to figure out is I'm trying to figure out B. So I have to leave this as B squared. So this is the equation that I have to solve. So I'm not going to multiply this out just because I don't want to use a calculator. But what I'm going to do is I'm going to add this to the other side. So plus 4 times 9 plus 16. I don't know what that is. I don't really care at this point. Oops, not that. And what I'm going to end up with is, it's going to look weird right now, but 4 times 9 times 16 equals b squared. Now, the reason I didn't care too much to do that is I know what my next step is going to be. I have to square root both sides. The reason I didn't care too much is I know that these are all perfect squares, so the answer is going to be 2 times 3 times 4. Now, I do care because I do have to give an answer, but this is going to be a lot easier to multiply than before. So 2 times 3 is 6. 6 times 4 is, well, 24. So 24 is going to be B, and that's going to be my final answer. So if I make this 24, I'm going to have one real solution. And if I wanted to check, it would be a parabola that just hits the x-axis once. So it would be one of those that just hits at 0 just one time. It doesn't pass through, and it also doesn't miss it. So we're looking for one hit in this case. So it is possible to do a little guess and check work to try and figure this out. You're more than welcome to do that. But if we want to do it the fastest way, probably the discriminant is going to be the fastest way. If you actually want to know what this is, again, you could type it into Desmos or your graphing calculator or regular calculator for that means. 4 times 9 times 16, 576. If I really want to know what this green number was, it was 576. I don't really care that much though. For 19, determine the number of real solutions of the system. So in this case, again, the number of real solutions for the system is going to be the number of intersections. So I'm going to go ahead and throw it into Desmos and do it that way. We could do it by hand, but with that 1/2 x there, I don't really think there's going to be much of a play on this one. All right, so we got x squared minus 1. I think we have like 1/2 x plus 1. What we had? X squared minus 1, 1/2 x plus 1. All right, and we see we cross twice. 1, 2. So there's 2. And that's it. So that's it. We're just looking for how many intersections, how many places these cross. So again, this is a situation where it crosses twice. If this was like and it's 10, then you can see they don't cross at all. So the answer would be 0. And if they just met at one point, then we would have an answer of 1. All right, final question then. Solve this. Negative 2x squared plus x plus 5 equals negative x minus 4. Give answers to 3 decimal points. So that right here where it says give answers to 3 decimal points, that's a good hint that this is a calculator question, because an exact answer would be where you want to give a fraction. In this case, we don't have a fraction. We want to do 3 decimals, so it's a good one to just solve by graphing. Negative 2x squared plus x plus 5. We'll switch this up. Give 2x squared plus x plus 5. Double check if that actually is x. Yep. Negative x minus 4. And so we get our 2 solutions. We're just going to steal those again from the graph. We're just looking for where those 2 things intersect. And again, since there's no y's in this question, we do not give the y values. We're looking for x values only because it only has x's in the question. So if you give me the coordinate points is wrong. Do not give me the coordinate points. The 2 answers are the 2 x values, negative 1.679 and 2.679. That's kind of cool. And that's it. So that's all of them, and we're all set. So that's the end of the Unit 2 test review.